You all are able to see my screen?
Yes, sir.
Okay. Yeah, good afternoon to all of you. Last class we saw what a queue is. We saw linear queue. In linear queue, the elements are get stored one after the other, and once you reach the end of the queue, we declare that the queue is full. But one problem with this approach is that when you're adding elements to the queue, you might probably be deleting from the queue also. So the front index will also be moving along with the rear index. Uh, in that case, even though there is enough space in the array, we are unable to utilize because the rear cannot reset back to the beginning of the queue. Now in circular queue, what is done is instead of initializing front and rear to -1, we initialize them to 0, 0. And the queue addition starts from index 1. Let's say we insert an element 6 here, so the rear alone moves, and then if we add one more, the rear continues to move like this. And when you want to delete something from the queue, the front has to be incremented by 1, and then that element should be deleted. So front, if it moves here, then this can be marked as deleted. So the front will always be one step behind the rear. But if front coincides with rear, suppose front again moves to delete 7, you will see that rear becomes equal to front, and at that time the queue is empty. So this is the arrangement in circular queue, and as the rear moves, if you go on adding further elements like this, you will reach the end of the queue and rear will be pointing here. Now if you observe, this portion of the queue is empty, isn't it? There is nothing stored here. So if I erase this part, so there is enough room for the queue to accommodate more elements because the front is pointing here. Okay. So now what I need to do is I must somehow reset this R back to 0 if I want to utilize this part of the queue. Okay. Now how do I do that? As you know, if you take an array of size 7, the indices will be from 0, 1, 2, 3 up to 6. So up to 6 there is no problem. But after 6, that is when you increment rear by 1 with r is equal to 6 adding 1, when it becomes 7, this 7 should somehow become 0. That is possible if I take mod of 7 with 7. Right? That is, you just have to make r equal to r plus 1 mod size of the queue, whatever may be that size. Now in this case I have taken 7 as the size, right? So rear will be here and you can insert another element, let's say pi. Okay, so still there is room for adding one more element because the front is now pointing at index 2, right? So one thing to observe that we cannot fully utilize the array. One element has to be blank because here if we insert one more, the rear moves and front is here. Okay, now I cannot move rear again. In that case rear will again coincide with front and the queue is empty or in this case queue will be full, right? So you have to see that the rear doesn't coincide with the front. So the condition that rear equals to front indicating queue is empty, that must be maintained. And when will I say queue is full? When rear plus
Rear
1,
is less than front minus
yeah,
1.
rear plus 1 coincides with front, then there is no room for the data to be added. So same this array can be visualized in a circular form like this. So initially front will be at 0 and rear is at 0, 1, 2, 3. Like this it goes on. Okay, so when you reach this point, that is when rear reaches this point with some element, let's say 9, the queue is full now. Okay, so if whenever rear plus 1 coincides with the front, then the queue is full. So this condition you must check. Okay, so let's see how I can implement this in a C++ program and make this whole thing work. Now we have seen the implementation of linear queue. So same thing we have to utilize this. Instead of linear queue, I will now name it as circular queue. The same array pointer will be there. Front and rear variables are required. Now in addition, we require the size of the circular queue. So in the constructor, I will initialize all these three. Front is 0, rear is 0 and queue size is whatever size I pass. We are not using this size in our linear queue. We are assuming max size as some constant and we are doing that. So the advantage is from the main you can decide what is the size of this queue. And array A is initialized with an array of integer elements of size queue size. Now in insert, how do I do the insertion? First thing is if front coincides with rear plus 1 mod queue size. As I was telling you, when you increment rear by 1 and take mod and check if it coincides with front, it means queue is full. Then I don't insert any element and I simply return from here. Okay. So if front is not equal to this value, then there is enough room for an element to be added. So before I add an element to the array, I increment rear index by 1 and take mod queue size, and then I say a of rear equal to x. So the insertion happens at the end of the queue. Deletion, we just have to check whether front equal to rear. If that is the case, queue is empty and you simply return without deleting the element. Otherwise you have to increment the front by 1, again taking the mod, because front also can wrap around. Once it reaches the end of the array, it can again wrap back to index 0. So it's not that only the rear can reset back to 0, front can also reset back to 0, because rear might have moved ahead of 0 after the reset. So front will be following the rear. So in that case, you just have to increment front by 1 and take the mod and return the element at index front. So this is how the deletion happens. And the display part, again you check whether front equal to rear, queue empty. Otherwise you take one variable I, and this I should be pointing at front plus 1. Remember, front will point to the queue one place before the queue actually starts. So it should be incremented by 1 and then assigned to I. And you put up an infinite loop while true. You output the elements at index I. Check whether I has become equal to rear. If so, you break it. Otherwise, you again increment I by 1 and again taking the mod. Because again I has to reset back to 0 once it reaches the queue size. Okay. So to demonstrate this, I just take a circular queue and insert, and here I have to pass the size of the queue. Let us say I specify size as pi. So when the queue size is pi, I can insert only 4 elements. So let's see what happens if I try to insert more than 4. So first thing, we will perform the insertion. The second element. So 4 elements have inserted. It can accommodate these many, and if I just say display, it will display those 4 elements. Let's see. Yeah, as you can see 5, 7, 3, 4 are the elements. Now if I try to insert one more, will it accept or it will say queue is full? Let's see. Yeah, it says queue full. That is because queue size is 5. I told you that one element it waits. You cannot store all the 5, only 4 are possible because one position is required to indicate that the queue is full or queue is empty. Alright, so only 4 are acceptable. But before this insert, if I delete one of them, delete queue, what should happen? 5 should be deleted and in that place 2 will be stored. But 2 will appear at the end. This time it will not say it deleted 5 and accommodated 2, as you can see. So 5 was at the front of the queue, that was deleted, and there was room for the new element to be stored, and that gets stored at index 0. Okay. And you will see that the queue is again in proper order. So circular queue is more efficient than linear queue in terms of the memory utilization. Okay. So did you follow what I have explained so far? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay. Yeah, I mean, I will give this as a exercise to work out and also share the source code. You try this out, and if you don't get it, you can refer to the code and see how the changes you could have done. All right. Now, what I wanted to do majorly today is discuss about the next data structure, which is a linked list. Probably in your undergraduate level, you might have learned what linked lists are. So linked list is a collection of nodes. So we define what is called as a node. Each node in the linked list has two parts. One is the data part and another one is the pointer part, which points to the next node. And each node is of exactly same type. That next node will also have data part and one pointer part. Similarly like this. So the first node will be pointed to by a pointer, we call it as head, and the last node pointer will be pointing to null. It will be null pointer, it is not pointing anywhere. Alright, so a linked list consists of array of nodes which are dynamically linked or linked through pointers like this, and linked list is a dynamic data structure. It means it can grow and shrink as required. Now, for example, if I want to add one more node to this, let us say at the beginning of the list, I want to add a node. So there are three possibilities. You can add at the beginning of the list or end of the list or somewhere in the middle of the list. So let's see how we could have done adding the node at the beginning of the list. So whenever you want to add a node, you create a new node, call it as new node, again pointed to by pointer like this. This will also have a data part and a pointer like this. Now to make this beginning of the linked list, what you have to do is you have to say new node arrow next. Assume that this pointer is named as next. So new node next will refer to this part. Okay, this you have to set it to head. When you do that, this points to this linked list. Okay, and now if I make head equal to new node, this head is removed from here and that will become that will point to the new node like this. Now you see that new linked list is formed with the new node being the first node in the linked list. Okay, so these are the two steps which are required here to perform add node. Add node is an operation. You have to pass some value x, and this x will be stored in the data part of it. Okay. So this is adding a node. Same thing if you want to add a new node at the end of the list. Then what you have to do is you have to take a pointer, temporary pointer t, which will be initially pointing to, or initially it will be copied from head. It means t will be pointing to the beginning of the linked list, and you have to traverse this temporary pointer till the end. That is while t arrow next not equal to null pointer, t equal to t arrow next. So when you run this loop, what happens is t will move to this node, then to this node, then to this node. When you reach this node, t arrow next will be null, so it will stop here. Okay, and now you create a new node which again has data part and a pointer part which is maybe initially null like this. Now to make this new node part of the linked list, all that I have to do is t arrow next should point to new node, isn't it? So this will point to this node, and that's all. Anyway, the next of the new node is null. You don't have to do anything. So as you can see, this new node has become part of the linked list. Okay, so this operation we can call it as append node, where you take a pointer t, traverse till the end, and just execute this operation, t arrow next equal to new node, and you are done. Okay, so this is about appending a node to the linked list. As you can see, the linked list is growing dynamically. Similarly, if you want to insert a node somewhere in between the linked list, or you want to perform an insert operation, let us say you want to insert after element x a new element y. So x is an existing element. Let us say the x is here, and you have created a new node with y. This is null initially. Now again you have to do t equal to head and check. You set up a loop while t not equal to null and t not equal to x, or you can set up a loop where you can check this while t arrow data not equal to x, you just go t arrow t equal to t arrow next. So until you hit x, you just go on comparing, right? There is one problem. Probably if x does not exist, then t will become null, and that checking you have to do outside the loop. Okay, so moment it becomes equal to x, it will come out. So let us say it has become equal to x here, t has reached this point. Now to make this node part of the linked list, you have to make a couple of changes. You have to say, first thing is you have to make the next of new node point to this. How do I do that? New node arrow next equal to t arrow next. You know t is pointing to node x. So t arrow next is this node. Okay. Let me remove this first. So T arrow next is this node, and new node next should point to this. And now you have made this point here. I can take off this link and make it point here. How do I do that? Again, T arrow next equal to new node. Okay. So now you see that linked list has accommodated a new node which is in between. That is, after node with value x, the new node with value y is inserted in between. Okay. So these are the three important operations that we want to perform. You can also have delete a node. Again, same thing, you have to traverse till you find an element which you want to delete and stop before that, and you have to bypass a particular node and free it. So that part we shall see later, but let's see how we can append or add a new node and perform this insert a new node in between. Are these three operations clear to you?
Sir, I joined little late.
Yes.
Can you please give an overview?
Okay. See, somewhere in your undergrad you might have learnt about linked list. Linked list is a dynamic array. It can grow or shrink as required. So, linked list comprises of nodes. A node is nothing but a structure or can be a class which contain two parts, data part and the pointer part, and they are linked to one another like this. You can perform adding a node at the beginning of the list or to the end of the list or somewhere in between. So these are the three important operations in the linked list. Of course, you can have one more, delete a node at the beginning of the list or at the end of the list or somewhere in between. Okay, so during the implementation I will explain to you what all these operations are and how the whole thing works. Okay, so let me take you to my program here. Okay, now how do I define a node? So class node, I have made the data and the next pointer both public because I will be accessing these two outside this class later in my one more class. Okay, so there is a data part in the node and there is a pointer. Now observe that this pointer type, that is next pointer, is exactly same type as the class, that is node type, because the next node is having exactly same structure. It will have a data part and a pointer part, and in the constructor of this I'll be accepting a value x and initializing that to data, and the next pointer will be made null. Okay, so which if whenever I create an object of this type, that is if I say node n1 5 or 4 whatever, what exactly is happening is you are creating a node with data as 5 and the next pointer of that is pointed to null. You can do it like this, or you can create a pointer n1 and say new node 5. So now n1 is a pointer pointing to the new node, and the node's next pointer is automatically set to null. So what basically has happened is that you have created a reference variable, a pointer n1. You created a node like this where the data is set to value x, whatever I was passing. I was passing value 5, and this next pointer is pointing to null. Okay, so I can create a linked list by creating these nodes and linking them in main only, but better still is you create a class which will do all these things with appropriate methods. So I would call, and I would create one more class here. Let me call it as linked list. Now this linked list has a pointer called head. So head is the pointer pointing to beginning of the list. Now within the constructor of this, I will initialize the head pointer to null. Null PTR, isn't it? Okay. So initially the linked list is empty. All of you agree? Now if I want to add a new node, I have to write a method add node and take a variable x or value x. So the new node which you create will contain data as x, and that will be added at the beginning of the list. So to do this, first thing is I create a new node and pass this value x. So as you know, new node is a pointer pointing to the newly created node with value x as the data part of it. Okay. Now here you have to check if head equal to null pointer, it means initially there are no nodes. Simply you have to set head pointer equal to new node and just return from here, isn't it? If initially the linked list is null, you whatever newly created node is the first node. Okay, so you take care of the boundary condition. Now if head is not equal to null pointer, then you will enter the else part. It means there are already existing nodes and you have to make the new node as the beginning of the linked list. So as I told you, new node arrow next should point to the head and head should point to new node. So this will ensure that the new node is added at the beginning of the linked list if linked list has at least one node. Okay, so this is adding a node at the beginning of the list. Now let's see how I can do append node. Appending is adding a node at the end of the list. So again I create a new node. Okay. Now I take a temporary pointer and initialize this to head. I have to traverse till the end of the linked list, that is till the last node. So while t arrow next not equal to null pointer, t equal to t arrow next. So when you come out of the loop, t would have reached the last node. Okay, now t arrow next should point to the new node which you have created. That's all. Okay, again you have to take the boundary condition, that is if there are no nodes, then append should make the first node only the new node. So you have to check if head equal to null pointer. This is quite a possibility, right? You may call append node at the beginning of the new linked list where linked list is empty. So if this is the case, again you have to make head equal to new node and return from here. Otherwise, you continue like this and you make the last node as the new node in the linked list. So these are the two operations we have seen. Inserting in between we shall see subsequently, but let us see if we can display this linked list and check whether these two methods are working correctly. Void display. It doesn't accept any arguments, so I take a temporary pointer node star t, which is set to head. So while t not equal to null, because we should reach till the end, right? Not t arrow next equal to null, otherwise the last node will be left out. Cout t arrow data, you display whatever that is there, and before you loop back you should make sure that t is advanced to the next node. So t equal to t arrow. And again you have to take care of the boundary condition. If head equal to null pointer, cout linked list is empty, and that return from here. Okay, so my linked list is ready. Now I create a linked list, call it as list, and list dot, I will append or just add node, one more, list dot add node, list dot add node. And now if I display this, what should happen? Add node is at the beginning of the list, so first 5 will be added, then before 5 7 will come, before 7 3 will come, so 3 7 5 should get displayed on our output. Let's see. 3 5 3 7 5. Is that what is expected?
Yes.
Isn't
Because
it?
we are adding from the head.
Yeah, we are adding from the beginning of the list, 3 7 5, in that order. Okay. Now after displaying, you can appending a new node. Okay, so let's see if I append, what happens. If I say list dot append, so what should happen? And if I display it, eleven should come after 5, right? What happened? As you can see, 11 has come after 5. It is appended. It is added at the end of the linked list. So far you have understood? Would you like to try this out?
Yes.
Yeah, you just give a try. We will see the insertion little later once you are done, because that requires little more complicated logic. Yeah. Just check if other part of the code is correct. This next should be pointing to null in your node. The initialization should happen correctly, otherwise if it is not pointing to null, it will not work.
It looks to be correct, sir, but still.
Now what is happening? The list is not coming, right?
Yeah, whatever I append, right, it always says empty.
Oh my god. After append,
Just checking here the list. Just comparing, it looks same.
is it head double equal to written? If head,
Yeah, I have given. Oh,
if you make it single equal to, it will make it
yeah.
null, and that's why it says empty.
Yeah, yeah.
That's the only thing.
Yeah, got it, sir.
Got
Thank
it,
you.
no? Okay, yeah. Okay, now what remains is how to insert a node in between. So for that, again you can say insert node and pass two values now. X an existing value in the linked list and Y is the new value that you want to insert. And you take a temporary node as before, initialize it to head, and you have to traverse till the node which contains that value X. So while t arrow data not equal to X, t equal to t arrow next. Okay, and when you come out of this loop, you just check if t equal to null pointer. You just have to say cout X is not in the list. And return from here. Okay, otherwise you know where this thing is. Now you create a new node and pass Y into that, so that Y is initialized with the data part of the new node. Now what all manipulations I have to do? T arrow next, it will point to the next node after this. So this should be assigned to new node arrow next. Node arrow next is equal to t arrow next. So the new node points to the next node after X. Okay, and now t arrow next should point to the new node. Am I right? So that the new node Y is inserted correctly. So there are two steps here. The next of the new node will point to the next of the node containing value X. So subsequent node it will point to. For example, after 7 you want to insert, so the new node next will point to 5, and this node 7 next will point to the new node. Okay, so let's see whether it inserts the node after something. So after this, here if I say list dot insert node, so let's say I want to insert after 5 some number 9, and if I say list dot display, so here you can give a cout inserting a new value in the list. So after 5, 9 should come. So as you can see, inserting any value in the list, after 5, 9 is inserted. Alright. So just see if you can implement this also and see for yourself how the insertion is done.